We are live,
Okay. I'll just wait for it to load on this end.
and I'm going to make some posts, or I guess comments. We
Oh
are
yeah,
live.
I can hear my stupid voice. Okay. All right, I'm gonna close it. Okay. So we are live. Not prepared, but we're here. Even though we had plenty of time to prepare, I'm still not prepared. So I guess
Yeah, but technology doesn't wait.
no, it doesn't. I always have issues, and first was sound, and then it was going live was an issue. Um, but here we are. So we're gonna have a little chit chat, our Space Weather Weekly, but kind of bi-weekly because we did a live stream earlier. But now it's just the regulars are here. Um, guess I suppose I should give you sharing privileges. But today we're gonna talk about the current situation of the CME that hit a couple hours ago from the infamous X-class flare that happened a couple days ago. It's a pretty meaty one, but it's got some strange things going on with it that we're gonna point out here. Uh,
Strange is a very good way to phrase that.
yeah, it's just kind of weird. So
So,
we're gonna start off with this, and then we're gonna talk about substorm characteristics.
which I think really is a very important point for everyone to at least somewhat understand. Whether or
Yeah,
not they understand the science behind it, that's another matter, but understanding its connections to how the aurora looks during the different phases,
and like when
because it
you're
will.
out and you're looking for if you want to take a break, and then if you know what you're looking for, you can kind of do such things. So
So, moving into what we have currently, I will start with saying it looked good upon first arrival.
yeah, it actually had a pretty good punch. We were all kind of like, okay, all right, this is decent. Might have to go somewhere later, maybe. I don't know. Probably not, but
Well, I guess that brings us to the ultimate point of what's going to happen now. So, we had an arrival about 13:36 UT. So here in, we'll just say Central Time, that's 5 hours beforehand. So 8 a.m., roughly 8:30
yeah,
a.m.
it was. Yep.
We had an
I remember
arrival,
waking up to all those texts in the group. I was like, oh, well, it's here.
which for cycle 25, I wouldn't have expected anything less than it showing up right early in the morning in the US. So that's
Yeah.
not a surprise.
Our friends on the other side of the planet, though. I mean, they'll have fun with it.
Hi, Aussies,
Yeah.
and those Tasmanian, New Zealand's. I don't know the specific terms for those, but the point is, there at least have been some, I want to say some daylight or some evening time Aurora 2 over in Europe, from what I've seen from cams. It
That's
looks
cool.
pretty good though. IMF went up to anywhere between 18, 20 nanotesla, so we're talking all negative BZ for that. That easily could get us to G3 levels, and it did for a very
Yeah,
short time.
did.
BZ is heavily oscillating, however, so it's not very consistent. And then the interesting part came at, let's say, 16:45. So actually, this wasn't that long ago.
No.
12:45 for me. So 11:45 Central. So about 3 hours ago.
Yeah.
We had not only the IMF power drop, but we had density increase and we had the temperature drop. And I mean the temperature drop to pre-shock temperatures,
Yeah.
which, as interesting as that sounds, normally that only happens for, say, if a core has shown up, A, or if it's gone back to just regular solar wind conditions. Both seem kind of unlikely at this point, given how soon it is. But it hasn't recovered. And not only that, it's decreasing further still,
Yeah.
which is actually, what is BX going to be?
So that's
That's a
pretty central, though.
decent
Like,
component. Yeah, I'm not too sure. The
yeah.
idea was the CME didn't look like it was going to hit us directly, regardless. I know the models were showing up as that, but from a stereo wave viewpoint, it did look like it was just barely skirting the Sun Earth line. So I was myself at least expecting more of a southern edge of the CME hit. So a core, maybe, maybe not. Theoretically, this could be a kind of a flux rope. It's hard to tell, but we'll know more after later on. But the point is, the IMF hasn't recovered. We're still sitting now at from decent magnitude IMF strength to almost, I won't say nothing, but we'd be lucky to see probably G1 parameters, assuming all negative BZ, which also is not happening. We've got a primarily northern BZ now.
Yeah.
So Aurora is likely to be stifled until we see something different happen, at least over the next, or for this evening. We're going to have Aurora probably the next hour or two, but that's irrelevant for North America.
Yeah, we still have plenty of hours of daylight left.
So much daylight. At this point, I think the UK still has daylight. So if that gives perspective to anybody else.
But yeah, this is what we're dealing with right now. It started off
So yeah, that was looking great. And now not so much. Things could, of course, change. I've seen shocks do this where they'll drop an IMF strength for hours at a time, and then once the core hits, it'll jump back up. Uh, Nobody knows. That's just impossible to tell at this point. So we just have to keep watching the data and see what happens. Too early to give predictions for the US anyway. So I'm not too terribly worried about saying yes or no to going out tonight.
I mean, you still have to deal with the moon, but that's okay.
Oh, right. God, I always forget that factor. Yeah, we've got what, a 90% moon tonight?
90%. When I checked it, it was like 90 point something percent. So
So if you were hoping to see color out of dim aurora, you might be out of
yeah.
luck.
I've noticed though in the times, and I think Sandkelp brought this up the other day, uh, when we were out in December, like it was nearish kind of, it was, I don't know, it was 67% moon, I think. But the reds were actually quite visible. And I think it's because the moonlight's triggering more of your cone, is it cones or rods that color? I forget. I mix them up
Don't
all the time.
remember the two.
But one of them, like your color reception starts to come back. Because we noticed like a lot of red, and I'm like, I don't remember seeing red like that until the other day. Um,
The red can
so
get
I
pretty
mean,
overpowering.
you might be able to see some red out, maybe some reds. That is if this turns into something again later. So we just gotta wait and see. But the takeaway here is the CME's here. This is the what we've been waiting for. And actually it came relatively
Early-ish.
within the time frame of the predictions too. So it wasn't too far off. It was
No,
pretty decent.
I was pretty impressed with about the same speed that it was expected to bring in too.
Mhm. Yeah, so
At
that
least for NASA's. I think it was NASA's model that had that coming the earliest.
yeah, and NASA had it the earliest. I think NOA had it like it was pretty much on the 18th, and I think Huxt even had it pushed a little bit further. Um, so yeah, it's here. For anybody wondering, it's here.
The only other point I want to make is now the interesting thing we have going on with the density. So depending on which satellite you're looking at, and I'm not sure which one like the apps use necessarily. I think it just uses the active, but Discover and ACE are now reading separate values for the peak of a density curve.
Oh,
As of I want to say that's about it for here. 1600s about an hour and a half ago. Density with at least ACE hit about 60 particles per cubic centimeter, which is still pretty high. But
yeah.
Discover was reading values at about 100,
Oh, wow.
which
Yeah, that's
so
pretty.
actually here let's compare. So 52, I thought I saw, yeah, 61, I think was the highest I saw on here. And then going back to Discover, it hit just about 100
Yeah,
or just over 100.
that's a pretty big difference there.
Mhm.
But that's
Now,
why.
I will say, at least in this, if you
Yeah,
check out the bars, and this is they're hard to read sometimes, especially with how small it is. In fact, let's go ahead and go to the 6 hour view instead.
yeah, because it has
There we go.
red. So
It
red
does
at
have red underneath that whole value. From here to about here, which is when the peak of that is forming, there was definitely a density peak. Right, that's pretty clear. And Hamilton brought this up as well, so we might as well bring it up too. GOES magnetometers are right now, GOES satellites are on the noon side, the day side, so they were pushed outside of the magnetopause very shortly, to be fair. But these big negative numbers are basically our shield getting pushed inward, so they're being exposed to more variable solar wind magnetic fields. That definitely usually helps with big density peaks. So the density peak is real, I can say that much at least, but the actual value is kind of up for
iffy.
grabs, I would say. Yeah.
It's pretty
I
neat.
would like to assume ACE is accurate in this case.
It's pretty neat to see goes pushed out.
It's happened quite a few times this year too, or this cycle at least. I want to say this is 3 or 4 for just the last, well, this summer since
Yeah,
May.
it's active. We're active.
Yay. It's so nice to have an active time period, but we need it at night.
Mhm.
Come on, son.
Yeah, that we do. Not this daytime stuff, but I won't
I mean,
even
you
go
know,
into the
it's,
weather stuff. I maybe not today because I did it the other day. But that's the
do we
other
have any
thing.
changes?
I've heard that it's cloudy now up north. I heard. I haven't looked at anything, but yeah, definitely. If you're gonna go out, check the weather too. I just always got to put that disclaimer in there.
It feels pretty important to mention every time. Yeah.
Yeah, check your earthbound weather.
And likewise, make sure to check the solar wind data because at this point, I wouldn't go out for what I'm seeing right now. Not
No,
at all.
especially not with a full moon.
Yeah.
It, it's not really I value sleep in my old age, so um I would sleep through this right now.
Point aside, a wise advice. Unless you're in Canada or let's say Southern Alaska and this is what you get, then yeah, I might go out for this.
Yeah, it might be halfway decent.
Which I want to say there's enough dark now for the Comer Anchorage
It's
area.
coming back. Even I think Fairbanks is starting to get, it might still be a week away from
I
where they
think
can
it's like
really
the
see it.
20 number
Yeah,
for when
somewhere
they
around.
start getting astronomical twilight.
But they're getting it back. So soon Fairbanks will be back online and we can check those webcams again.
And I'll be jealous of what they get to see normally.
Yeah, which is
It's
like
my
every
favorite part. That's all I've got for solar wind data, at
okay.
least.
So I guess we can go into this paper. So let's see. Well, we have this cool paper to talk about.
Actually, here, do you want to share yours?
Yeah. Well, because it should all be added in here, I think. Yep. Let's see.
Oh, I've got the doc too. That's true.
Yeah, I mean, you can put it up if you want. Um, so this paper, I will preface this by saying was way over my head. Just was. But there's some kind of fun takeaways with this. And as you can see by the title kind of grabs you. The explosive characteristics of the Aurora. Because the three phases, you got growth, expansion, recovery. And the expansion phase is the phase that we're all kind of, giddy about because that's where all the cool stuff happens. It's very explosive, like it says in the title there. But what's neat about this paper is it takes a different approach of looking at it. It's more of the electric current line versus the magnetic lines. And long story short, it's like it's just a different way to look at it. It kind of makes more sense since what we're seeing is more of the electric end of it. But it needs more investigation. This is relatively a new way to look at it, and they even say in the paper that they want the younger generations to look at this further to see if they can
Yeah.
connect things better. Um, so I will just start with which is funny because it's further down in the notes, but like what the growth, expansion, and recovery phases look like, and then we'll talk about this tipping bucket analogy because it's quite fun. So where did I put that? So your growth, yeah, actually this we can leave that picture up there. Is the discrete arcs on the horizon that you kind of see. You know, like when you're out and you just see this glow on the horizon, which is something that, when you first see it, it's like cool, but then after you see a bunch of storms, you're like, yeah, I'm gonna go to bed. This isn't very fun. Um, but then the expansion is the sudden rapid poleward advance. And this is where you get the dancing and the movement and the pillars and all the craziness that everybody gets excited about. And as you see, it can be very intense. It could, average speeds, it moves at like 200 meters per second, but it can be like 500. It can just explode. And the figure that is on the screen kind of shows how that can happen. That's an all sky cam, so it quickly goes from, kind of just advancing up to like the whole sky. And this is kind of what we saw on Sunday. It was very, very explosive like this. It was around like 1:30 a.m. Central Time, and it just went, oh, I mean, it was pretty wild. So that's what we're interested in. Recovery phase. There's some interesting things that can happen in recovery phase, but this is when it all retreats back up into its home in the Arctic Circle. And it's patchy pulsing aurora. I actually like the pulsing aurora. So the recovery phase is kind of cool. The other note to take here is that substorms can overlap. They don't merge, they can overlap. So you can see different things happening at the same time. Like I have seen this before where you get like some pillars, but you have pulsing. So you have this overlap going on. And that's usually when you have, a driver behind it, like what we're seeing today. You
Big
can,
CME.
yeah, a CME, you'll get like these bumps. And yeah, it's fun. So that's kind of the phases in a nutshell. What I should note here is that when we talk about, I don't know if I even noted yet, but there's directly driven current, which is like the background. This is what's every day. Now this is where we're going to get into the tipping bucket thing. so we can find our, I'll actually bring up our tipping bucket. I love this analogy.
Same.
So basically
Such a
what
good
it
layman tool.
is you have your factors coming in. In this case, you have IMF, BZ, that's all your inputs into the magnetosphere. It builds up, and this is where your directly driven current comes in because you always have this background and it's always dissipating, but there is a point where it can't handle it anymore and it tips over. And that's what you see in the middle diagram there. That's your substorm. So that tipping bucket is this substorm going on. And then it goes into recovery. All the stuff goes back in and it repeats itself. Repeats itself.
And I
But
think May was a good example, or at
yeah,
least the May storm of
yeah,
the multiple substorms all at once.
yeah, it really was. Like all of a sudden you'd have this explosion again, and then it kind of retreats, and you have it again and it retreats. And this is something that happens on basically a regular basis. And it's kind of neat to point out because when you're out there looking at Aurora, if you can identify these different phases, then you can, A, know what you're looking at, and B, you can be like, well, okay, I'm in recovery phase. Maybe I'll find somewhere else to go until the next one comes on. It's I found that this was probably the best visual example of how this works. So even though this paper was extremely over my head, I talked about the electric lines and stuff, but this right here, this little document, um, was really the key takeaway of the whole thing, in my opinion.
I think so too, honestly. And it's good because not only that, but they can separate the two components that are there. So you've got not only the tipping bucket analogy, but then the pitcher analogy,
Yeah,
and both of them are accurate to a degree. So then you've got diagram C here, which is really the main idea of what is behind a substorm usually. But if you want to look at the parts individually to know what's going on there, you can go to either or. Because yeah, you've got the main component that's always being driven, but sometimes that's not enough, and then you get the substorms that come in and get rid of the excess energy from there. So if you're like in Alaska, let's say, or say northern latitudes, especially, I think it's more important then to connect, like she already explained, the stages of the aurora as it is during these phases. And a lot of people end up going home or getting bored. It's, let's say, 11 p.m. You're in Iceland or Norway or Alaska or northern Canada, and you just see a faint band that's overhead. Maybe it's not doing much or moving much, but that means it's not time yet. And usually that leads to then your substorm factor or substorm phase, which is then it'll get bright and expand and go towards the north and explode all overhead.
yeah.
But a lot of people give up too soon. So the idea is those little tiny bands, they're going to move more equatorward, usually more towards the south, depending on where you're at. There'll may be some other smaller bands forming behind it, and then they're just going to explode over time. But it's
And
usually short.
yeah, it's usually short, especially when there's no external driver. That's the key here is like if you're just doing everyday average chasing up there, which is kind of what I ran into in March because there really wasn't much of an external driver at all for the whole
Uh,
month. Then you really are substorm hunting. Like you're looking for this because it's and I think I wrote in the top. Where did it? I just want to make sure I word this right. Because he mentioned it was like around basically kind of tying in magnetic midnight is when you're gonna want to really look for um expansion when there's nothing going on.
oh,
I
hey.
thought I thought I wrote it somewhere, but I guess maybe I didn't. But that's an important thing to note is local magnetic midnight on that. So now we can talk about how to find it in magnetometer data, which is down below.
Thank you, Tanya, on that note for loading that.
Rolling that there. And if you want to take over this part, you can.
Sure. So, at least for some good examples of them. So, as we've always tried to advertise magnetometers, or at least I shouldn't say necessarily just mags, but tools that are a little more helpful in getting you aurora at least closer to the time it's going to occur or closer to know that it has happened or will be happening. You notice we've stayed away from other different types of tools that a lot of people use. And that's because honestly, the error range is just so wide that it doesn't seem that useful, especially if you're someone that really wants to see the aurora. So in this case, we've got, these are called stack plot magnetometers. They're individual magnetometers spread out in latitude. So you've got one line, you've got two lines. These are all in different places, generally amongst a line across the globe. The idea is though you can recognize substorms. So is my mouse visible? I should probably point
Yeah,
that out too.
yeah,
Cool.
it's fine.
So
You're good.
circling at least, let's look at this line just for the fun of it. This would be a decent substorm example of a expansion and recovery phase. You've got the decrease in value, and that's generally what you're going to see when you've got the expansion phase going on. And then you've got your dipolarization here at the very bottom, and then a return to semi-normal values. And now I should say, when was this done? 34th, 1st of July. This is going to not have more zigzags on it. Generally, this is aggravated from probably from a high negative BZ or at least some sort of negative BZ. This is driven in some different way, though. Normally they're calmer than this. But the idea is if you start seeing a descending magnetometer, especially in this case, and make sure this is the H component. Yes, good. These lines especially, this is the aurora in progress. If you want to simplify it as much as possible, when you see it drop, that's when you should be outside.
Yep. That's and that's
That's
about
pretty much the moral of it.
yeah, that's the moral of it. In magnetometer data, you can actually hunt for substorms. And I want to so without going too far into it because there's the different components to magnetometers, but I think they default to H component on the apps.
Yes.
I think.
You can
So
go to the main, if you're on the main website, you have to pick it, I think, but the apps
okay.
default to the H component
Yeah, so I
generally.
just want to make sure that's right because that's what we're showing here is that because you can use other components to look for different things, but that could be a topic for a different day. I know she was nice enough to put it in here,
To have that
but,
on there. I
but
think that's going a bit far too, though, for now
yeah,
at
it's
least.
like because you can actually tell in magnetometer data where the aurora oval is, which is pretty cool, when you think about it. But that's using different components. But for the talk today, we're just gonna stick to the H component, which is the default that you'll run into. Because you can see, like even in this one that he has up here, you can see where the substorm is. Like you just and
Yeah,
once
I
you
like this example too.
yeah,
So
once you know what you're looking for, you can see it. And then you can use this to dictate if you want to go out and look. Um, yeah.
so in these conditions, especially as we start getting to this is what also the 31st of July, going to 1700 UT, and then especially that giant spike up here, I would be absolutely outside at that point.
Yeah.
Then you've got some prep work going on. Let's see. Yeah, because there's definitely many different substorms, although it also depends on which side of the Earth that one's on. But the idea is the zags down. If we're going to be as simple as possible, zags down is what you're looking for.
So yes. And that's how you find substorms in magnetometer data. It's super helpful. I mean,
It
like
is.
the whole point of what we're trying to do here is try to give people different options to look at things that's more in line with real-time chasing, give you more success for lack of better terms. I know, if we go back to the whole because everybody uses KP. And if there's a big event going on, yeah, you'll probably see it because even with the 3 hour error or not error, but 3 hour window that's an average, odds are it's still going to be going on. But are you going to see the really cool part of that storm? Probably not.
The important part. Yeah.
Yeah, and that's where looking at this magnetometer data and knowing the different phases of the substorms can really help you in find and seeing what we like to what does Adrian call it? The expansion phase?
It's the
Yeah,
fun phase.
the fun phase. Yeah, so you can find the
I'm
fun
not sure
phase.
if those were his words exactly, but I think that's what I read. It's
And
what
that's
everybody wants to see.
yeah, that's what everybody wants to see. But I think we'll keep it at that for the simplicity's sake. Um, there was more to that paper, but it starts to get pretty heavy in advanced physics that I'm not even prepared to talk about. So I don't even want to pretend. I'm
I
not
think it would ultimately just not help the point of what really we're just trying to get across today as well, which is just the getting the phases of the substorms so that people can know what to see and what to expect from that. And I would
yeah.
say it's even more important to people that are chasing, say, in the U.S., mostly, especially in around the U.S. Canada border. You've got a lot of I don't want to say risk necessarily, but it's not like you're in Alaska where any tiny little bit of activity is going to get you aurora, especially visual aurora. You're going to need to know, is this building, is there going to be enough, or did I miss it already? Is it recovery? It just allows you to not waste your time.
Yeah. That's there's the moral right there. Will not waste your time. Because how many of us have been out all night They're like looking for the stuff, and it's like just waiting and waiting. It's like, is it going to happen? Is it going to happen? And so having these little extra tools is just going to help you immensely because, like I said earlier, when you get old like me, you start to value your sleep more. Uh, so being able to understand this is super helpful. Let's see, what else do we have the AE plot too. We could go over that, but I don't if we want
I
to
think,
touch on this because
and it
it
is a little easier to understand, of course, too.
yeah,
In fact, I might even advise it if you want to go and compare KP ovation or AE index. The AE index is going to give you at least a little more knowledge, and it's real data as
yeah,
opposed to past data or models
yeah,
like the
this
KP
is
or ovation.
near real time. I don't want to say it's exactly real time because I think there's like a minute delay or something, but it's as close to real time as we can get. But this is monitoring your the boundaries basically of the aurora oval, so upper and lower limits. The lower limit is the poleward. So that's kind of the important component here. You start seeing that dip down and then it's pushing. Um, Down below the AE and the AO, those are averages. Um, so anyway, you can look at that too, because anything above 500 is decent, especially in the more northern latitudes. You start getting into 1,000 or geez, I mean 2,000 would be amazing. Then we're in a big a big event.
They
Uh,
really need to fix the scale, I think, for this
yeah,
cycle. It's gone off the scale quite a few
it has
times.
gone off the scale a couple times. Like if we look at what's cool is they can go back and kind of correct it like after the fact. But the May 10th storm it overwhelmed this index. It overwhelmed it pretty significantly. They might have gone back and corrected it now, which would be nice. But yeah,
Nope.
I mean, look at this. It's just like this is where the AE index does not help you at all because it just gets overwhelmed.
I
It's
mean, look at this line here. You can't tell where this line stops and where the
yeah.
AL decreases down. Like they meet up.
I
It's
mean,
almost useless info,
yeah.
except to
I
tell
mean,
you
to
that
be
something's.
fair though, like if you see a index like this, I would hope you're outside.
Well, if you weren't outside on May 11th, that's exactly the point. Yeah, or at least the night of the 10th.
Because it's like it's all over the
But
place.
it needs to go up to like I think 3,000 or maybe even 5,000 to be safe for at least the remaining of this cycle, just so we stop having these moments.
Yeah, no, so yeah, it's a great tool. I love the AE index, especially when you're dealing with more minor activity because you can really see it.
This
You
is, I mean, honestly, today's a perfect example. You've got pretty much quiet level activity, almost nothing until you hit about
yeah, you get a
7
little blip,
UT.
and these are those tipping buckets. You get these little blips, and
So you had probably a good Aurora show here. I would say decent-ish, maybe visible
yeah,
on the U.S.-Canada border, but
that would be visible around the Canadian border for sure.
and then a lot of nothing, and then it got a little bit better, and then a lot of nothing, then a bigger one,
Mhm.
and then some nothing, and now we've got a giant one.
What was the date on this? It was
This is just yesterday.
oh, okay, yeah. So yeah, it's like you get some decent stuff. It's another tool to add to the toolbox on the substorms. Substorm hunting. That's what I'm gonna call this
And
substorm.
it's easier to understand.
Yeah, it
That's
is.
my
Like
favorite part.
yeah, like if magnetometers are too much right now, you can use the AE index. Um, that's it's just I don't know, we find it super helpful. But of course, if you don't want to learn any of this, we will do a plug for the Glendale app again.
Well said. One of
Because the
the
Glendale app basically
one of the
takes
best.
all this magnetometer information and puts it into a graph that tells you, hey, there's a substorm happening. You might want to be outside.
It just gives you the words, nothing more. But the words update every time something happens. So Glendale Ap.
Yeah, so
But for those
we'll
that want the AE index, literally you can just type it into Google AE index, and you've got all of these sites. They're all part of the same thing. I always just do the real time quick look, and then you can pick your day.
yeah,
Super easy to get to.
it's this obviously these science websites are not very aesthetically pleasing.
No,
They look like they were made in 1993,
yeah,
but they're basically data holds, so they're more interested in that than making it look pretty. Which always cracks me up. I'm
actually, I
like, oh
think
yeah.
what's the AE index goes back pretty far too.
Uh-huh. Yeah, it should. Should in 96, I guess it looks like.
Got
At least it
2000
says that.
there.
96 now, but I only see it on
Yeah, I
yeah.
can only find 2000. Oh, that's supposed to have it a little sooner than that, but
DST goes back a long ways.
Yeah.
Yes, if you really want to dig into historical data, DST will go back a long ways. So that's kind of fun when you want to go down different rabbit holes here and there.
And on that note, I guess since we're here,
Mhm.
DST index of the storm we just had on Sunday,
It actually was a pretty good dip. It was
it
pretty good,
was
pretty good hit.
minus two, what was it, 20 something? It was that the 12, 13. There we go. 203 was the lowest point for that, which puts it in the top three storms of this cycle, actually.
That's yeah, it was brief, but it was good. Should I bring up the maybe I'll bring up those pictures.
Yeah.
Yeah, so hang on, let me see if I can find them real quick.
While you're looking for the images, there was a question that was asked
Oh
on
yeah.
the interview that I can go ahead and at least address now when we had our Swipsy forecaster.
Oh yeah.
Someone asked if, or essentially how the interactions between eruptions that happen on over the Western Limb can happen on Earth. There are basically the magnetic field lines are curved from the surface of the sun towards the Earth. So there are better connections from the sun and events that happen on the sun closer to the Western Limb and over the Western Limb. It's a little less easier to get to. But the more energetic these particles are, the more they can curve. So if you have a super, super giant eruption, but it's way over the Western Limb, and let's say not facing directly opposite of us, but maybe a little bit to the west, you can still have energetic particles that are wrapping around and hitting the Earth, and we're detecting that on our sensors. Generally, the further west it is, the easier. There have been, I want to say, maybe two eruptions, at least since I've been involved in this, where an eruption happened directly across from us, and we still saw high energy particles coming from that.
Yeah,
It's dependent on the energy, though, of the eruption.
the backside of the sun, and we still got hit with a SEP, the solar energetic particle event. Yeah, that's just insane. But that's different, like for aurora purposes, that doesn't do anything for us. That this is more like radiation stuff.
Yes.
But
CMEs will, I mean, there's a slight diversion of CMEs. You'll have them slightly bend if they're on the western limb, let's say, and towards the Earth a little more, whereas ones that are on the eastern limb will generally bend away from the Earth a little more. But yes, it's far more relevant when it comes to the high energy particles, which are not generally aurora related whatsoever.
nope. So yeah, whenever you see what are they are not it's S's S the S
The S
scale.
scale. Mhm.
Yeah, on Space Weather Prediction Center. That's radiation storms. And some people will be like, "Oh, look at this." And like if you're doing aurora chasing, don't eat that
It's
doesn't
irrelevant.
it's
Yeah.
irrelevant. We're interested in the G scales and to some extent the R scale because that means there's a flare going on. Um, you know, gets our attention anyway. But yeah. So I will
These
share
get our attention a lot this year.
and for sure. So I will share this screen because we're going to talk about that dip in DST. I don't know if you see it.
Ah,
Uh, so
Reds.
in the Aurora Saurus meeting on Monday, we were talking about Great Red Aurora. And I don't think they officially classified this as that, but I think it might end up being that because it was great and it was red. And I've never seen red to this extent. And it was very fast. So when we go back to when we were talking about that tipping bucket analogy, um, this happened very, very, very quickly, and it also kind of seceded quickly too. I don't think it lasted more than 10 or 15 minutes, to be honest. But I like this picture because it shows where'd it go? Because what happened was it came in and it just pushed and pushed and pushed like to where I took that Corona picture, but it was extremely red to the naked eye. Um, it's the reddest I've seen to this date. It was pretty wild. And then I'll just show the other one, which I think is gonna be
So glad I was sleeping for this.
yeah, you were sleeping, but that's okay.
Everyone sensed the sarcasm there.
I know sarcasm. Oh yeah, that's not I don't want that. But where'd my other one go? Did I do it
I love how
right?
you label all of yours on that
I
note.
know I label them so great I can't find them. Okay, so this is the other
Oh,
one.
there we go.
This was when because I had two cameras going, um, and I had this one facing the other direction, but this is that bright red. Like I had to desaturate this, and it's still crazy, but it was just so we were
I
talking about
mean,
that
the
that dip.
reflections.
Yeah, it was even in the car. Like the car's paint's got pink in it. It's just um the point here is like it was fast and it was over. It was over pretty quick. I mean, did the Aurora go on after that? Yeah. But the point of this whole talk today is if you know how to look at this data, this magnetometer data, then you can find these points where it's really intense and then not be, like look at it later. It's like, how did they get that? Mine didn't look like that. I'm like, because it only happened for like 5 minutes.
Right time. Right
Yeah,
time, right
so
place, but you can be at the right time if you
uh
use all your tools.
so anyway, that concludes our podcast for the day, I think. Unless you have anything else to add.
I'm good.
But I think we're right around our usual half hour-ish. We might be a little over.
Yeah, we got a live CME. It can be
Yeah,
a little.
we got a CME to talk about, but we wanted to, kind of divert into more relevant topics. Obviously, if anybody's watching this, like if you have any ideas, like papers or topics that you want us to talk about, let us know because we can cover it. And I think that's, as Aurora chasers, I think we'd be more interested in learning about these different aspects of Aurora chasing that really aren't talked about anywhere. Everything is in academia, everything's an academic paper, or like, there's nothing out there for regular chasers. So we're hoping to bridge that gap and like try to, yeah, exactly,
Merge it.
merge it, get more information out there. Like this is what you want to look for, this, that, and obviously, hopefully, with time, we'll get better at explaining it in a way where it makes sense. Because I mean, I admit it, like from the start, I'm not a scientist. This paper's over my head. I don't understand any of this, but you can read it and have like takeaways, like the tipping bucket, for example, which I think was like such a great analogy.
It really was. I mean, honestly, I think that's going to be a commonly used one now, or it should
Yeah,
be at least.
should be. So anyway, that's our weekly update. If anybody's going out tonight, well, best of luck. Keep an eye on the data. Hopefully we get a bump back in IMF or something to
I
bring
hope
it back.
so.
But we'll keep an eye on it. It's here, so it's there. We got to keep tabs on it. But without further ado, we'll call it an end and see you next week.
See everybody.